Good afternoon, everybody. I hope you're still not too tired. My name is ULRIK ERIKSSON. I'm working for the robotics division, ABB. In the next few minutes, I will try to share with you some of the innovations that are currently taking place in the realm of industrial robotics. But before we start, do you know from where the word robot came from? I'm sure many of you know because it came from Czech Republic. It was delivered from the word robota, which means work or labor. And the first time it was used, it was in a play by Karel Čapek. And the plot is that humans were developing some kind of artificial life, and they put this artificial life to do all their work, take care of their economy, and in the end to wage war between themselves instead of doing all the job themselves. In the end, the robots turn against the humans, and if you want to know the end of the plot, I can recommend you read it. It's quite interesting. So, what are the current applications for industrial robotics? We find them a lot in the industry, making, for instance, spot welding, arc welding, palletizing, deburring, cutting, and so on. There's also robots in medicine, making surgery, remote surgery in very far places. We have household robots, cleaning your house, cleaning your pool, cutting your grass. There's also robots used in agriculture, which take care of the crops, and they can even harvest it. There are some space applications, like this one developed by NASA, and the idea is that instead of having humans doing the EVAs, extravehicular activities, which are quite dangerous, you will have a robot doing those activities. And there's also robots used in entertainment, and nowadays we have social robots like Sophia, which we will probably meet in a few moments. Some slides with some interesting figures. Between 2016 and 2019, there's been around 1.4 million industrial robots that are being installed during this period of time. So we estimate that by 2019, there will be around 2.6 million industrial robots working in our factories. So let's take a look at the countries. Which are the countries that have the highest population of robots working? It's not surprising that the three top are Asian countries. So we have Korea, Singapore, and Japan. But if you take a look at the red, all those red bars are European countries. So we have a very high density of robots in our factories in Europe. Czech Republic is listed somewhere with 93. It's above the average, actually. So a lot of people are afraid that robots are taking our jobs. Is that really true? If we take a look at the top 12 countries with the highest density of robots, we see that the unemployment rates are not so high. No, it's 3.6, 2.2 for Singapore, 2.8. So most of them are under 5%. So I would say the highest density of robots, it's with the lowest unemployment rate. And the reason is, which type of robot of jobs are the robots taking from humans? They're normally replacing humans in applications that are very routinely, that are dully, they're non-ergonomical or hazardous jobs. Like, for instance, welding. Welding is terrible for humans because you have this ultraviolet radiation that can leave you blind if you look at it. You have also infrared that can burn your skin. You have the fumes, which are poisonous, so if you're inhaling that for several years, you will have iron deposits in your lungs, which are not good for humans. So to protect you from all that, you need to dress up with protective gloves and a protective dress and a helmet, and in the end, you look like a robot anyway. So it's a perfect application for a robot. Heavy lifting, you don't want to be lifting heavy weights 7 days a week, because in a few months, you will end up with back in your pain and your pain in your back, and your column will be completely destroyed after several years. So it's a perfect application for industrial robots. Assembly of components. Imagine if you're sitting day after day just assembling the same component. That's not good for our minds. We need to think about something else, be creative instead of just assembling. Or foundry applications, which are exposed to maybe 70, 75 degrees in the air. You can only work like 10 minutes and then you have to go out or you'll be dehydrated. So that's also a perfect application for industrial robots. Or press tending, when you have some press that are only time-based. So if you're distracted by something happened, you're distracted, your limb is gone. So it's also a better application for a robot. There's been a lot of talk about that we're entering the fourth industrial revolution. So the first industrial revolution was when the first steam machines were coming and we started to manufacture some more complex things. Second industrial revolution, we introduced electricity in our factories, and we had the first production lines. So that was more or less when Ford started with production in serious production and so on. The third industrial revolution was when the microchip was invented, and then we could suddenly have programmable computers. The first industrial robots came. But now we're talking about the fourth industrial revolution, when you sometimes just unplug the cables and you connect to cloud services. So every single component in a production line, the robot, sensors, conveyors, everything will be connected to cloud services. And what can you do with with that connectivity? So, for instance, in a big production line, you can do things like condition monitoring and diagnostics. So you can see if a specific robot in a production line is working more than the others. Then you can do some preventive maintenance to that specific robot to prevent the line from collapsing just for one robot failing. We can do backup management. Imagine if, for some reason, an operator erases the program, and then he just needs to call the responsible, and from his computer, it can be on the other side of the world, he can download the latest backup to that specific robot and restart the line. Remote access is the same. You can get remote support. If there's a problem with a specific robot, you can call an expert, and he, from standing in Sweden or in China, can connect remotely and fix the problem. With fleet assessment, asset optimization, you can also look at specific signs of a robot and do some preventive maintenance. No? So that all that will prevent the line from stopping. Another innovation that we have at the moment is the collaborative robots. We have one out here in our booth, and I welcome you all to visit it. Collaborative robots means that people and robots can interact with each other without the need of a safety. Normally, industrial robots are dangerous. They're big, they're heavy, they're strong. So you always need a safety. You need a fence around it. You need some light beams in front of it. But with this, you don't need any of that. You can interact with the robot. If it hits you by any chance, it will not hurt you. It's made with very soft materials. And of course, it has its limitations. It doesn't move too fast. So it's limited in speed, and it's also limited in handling capacity. It can only handle up to 0.5 kilograms, so half a kilogram. We call this robot YuMe, and the idea behind it is because it's you and me working together. We also have, we're trying to introduce some virtual reality into the world of robotics. We also have it in our booth outside. With virtual reality, you put the glasses on and you're completely immersed in the virtual world. So you can see, for instance, a robot station complete. You can make some ergonomic tests to see if everything is at the right height, for example. And you can also look at the program execution and see if everything is in place, and so on. But we're also looking at mixed reality applications. The difference is that with mixed reality, you see the virtual components in the real world, together with the real world. You're not completely immersed in the digital world. So with this, you can see, we can have some service applications. For instance, imagine a service engineer which is not very experienced. He has a problem with a station. He can put the HoloLens on, and he can scan the serial number of a robot and connect to a web service that will automatically retrieve information specific to that robot. So what was the latest service done to this robot? Has there been any spare part changes lately, and so on. He can also download what we call SIM-structions, which are like assembly instructions in a form of a hologram. So if he needs to replace a motor, for example, and he doesn't know how to do it, he can put the hologram right beside the real robot and just follow the instructions. No? Remove this screw, and he does it. He can play it back, and so on. And he can also have remote support. If he needs the assistance of an expert, he can just call anybody anywhere in the world, and he can get remote support. The people behind the screen will be able to see what the service engineer is looking at. So if there's a fault inside the controller, he can look, and the support engineer can tell him, okay, you need to remove this specific connector, and he can draw on his computer in China, and the service engineer will see it drawn holographically, virtually, in front of him. So I think this will be a very powerful tool. There are also other applications. What this enables you is to see the invisible. Like, for instance, we have something called safety zones, which are geometric forms that define a safety zone, which beyond that, the human, if it passes, the robot will have to stop. But they're invisible. It's just a formula in the controller. So you can put this on, and you will be able to see, let's say, physically or holographically, the safety zones. You can also make some, in a factory, if you want to test how a new station, a new production line will look, you put it there holographically, and you can see exactly how it will fit. You can change it, place it wherever you want to see where it will fit best. Okay, it's also a little bit slow. Alexander was talking about artificial intelligence, and we're also implementing artificial intelligence in industrial robotics, mainly nowadays to analyze this data. I was speaking about connectivity and connecting a whole line, but imagine if a production line has 100 robots, and we multiply that by 1,000 factories, then suddenly it's a lot of information being uploaded, and we need an intelligent way to analyze all this data. So we're trying to use or implement some AI algorithms to analyze all this data, and in the end try to make some predictive maintenance. Imagine if by analyzing the current of all the motors, you can identify one specific motor that might fail in a few months. Then you can tell a service engineer, hey, look, motor 1 of this particular robot will probably fail in 2 months, and then you can take preventive action before you have a problem. And the worst you can do in an automotive line is to stop production, no? If it's not planned, because then you have to call service, they have to come, they look at the problem, order spare parts, and it takes a lot of time. And with doing this preventive maintenance, you will take action in advance. You can make a planned stop of your production, which will be reduce or increase the productivity by reducing the downtime. So we can connect all our robots, all our sensors, everything to cloud services. We have detected that leads about 25% fewer incidents, and it's about 60% faster response time for us. So by reducing the downtime, we always increase the productivity. So we have things, we have services, and we have people that access to those services. And that's why we in ABB, we like to call it the Internet of Things, Services, and People. So thank you very much, and I hope you can visit our booth to see the HoloLens and to take a look at the Yumi robot.